Hello, algebra students. Mr. Lawrence here with your next flip lesson, and today we are working on compound inequalities, and we are going to graph them on number lines. And these are really easy. They're just an extension of what we've already been doing. Let me hold on here and find a number line. Okay, I can get it just like okay, there I found my number lines. Now, compound inequalities are either or statements or and statements. And here's two or statements. And these are so difficult to do, let me tell you. See this first one, 3x plus 2 is less than negative 7. I'm going to solve this for x. I'm going to subtract 2 from each side. And that'll give me the statement, the inequality of 3x is less than negative 9. Then I'll divide by 3. I'll divide by 3, and x will be less than negative 3. All right, I'll put negative 3 on my number line. I'll use an open point, and I need numbers less than negative 3. Well, let me see, negative 4 would be here, and negative 2 would be there, and I will need a number. I need the numbers that are less than negative 3, and they would be this way. And so when I do my shading, I will do, oh, this is a pretty one. Look at this. Try to make it look like an arrowhead. Kinda does. Kinda. Okay, so there it is. All the numbers less than negative 3. Make that statement true. No, I'm not done with the problem because I have to go and do the second half of the problem. So here I'm going to solve for x, and I'm going to add 4 to each side, right? And when I do that, I'm going to get this inequality. 5x is greater than 5, and then I'll divide by 5, and divide by 5, and I'll get x is greater than 1. This is your solution. Not each part individually, but both together. X is less than negative 3, or x is greater than 1. So I need to show a positive 1 on here. And if I want to show 0 and 2, I can. And again, it'll be an open point. And I'm going to shade to where the numbers are greater than 1. Well, that would be to the right of 1. And there we go. It's just that simple, ladies and gentlemen. Can you believe it? All right, here comes problem number 2. It's also an or statement. So I will subtract 10 on this first part. And I will get negative 6x is less than negative 12. Then I'll divide by negative 6. Whoop, 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 whoop. Whoop, 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 whoop. Whoop, 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 whoop. X is greater than 2. Because I divided by a negative. So my inequality changes direction. All right, now over here I'll come and I'll subtract 6. And then I'll get negative 4x is greater than negative 4. And I will divide by negative 4. Whoop, 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 whoop. Here they are. Whoop, 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 whoop. Okay, x will be less than 1. So I get x is greater than 2 or x is less than 1. There is the solution. And to graph it, well, I'm going to have to show 1 on my number line. I'm going to have to show 2. I can show 3 and say 0 if I want. And I'm going to need open points at 2 and an open point at 1. And how am I going to shade? Well, x is greater than 2. Where are the numbers greater than 2? They're to the right of 2. All right. Or x is less than 1. Where are the numbers less than 1? Now, if you don't get the gist of what I'm doing here, I need to find a statement, a number, all the numbers that make this true or that make this inequality true. And what you'll find is that if the numbers are greater than 2, then this one is true. If the numbers are less than 1, then this one is true. With an or statement, it can't both be true. For example, let's say I was going to take Madison or Paul out for ice cream after school today. I'm not, but let's say I was. Who's going out for ice cream? Either Madison or Paul, not both of them. An or statement means one or the other. So I only need one or the other to be true. All right, now here's what an and statement usually looks like. You might see it as two inequalities. You could see it, written like this. Negative 6 equal to 3x plus 9 and 3x plus 9 less than 21. Okay, but I don't like to do it that way. I like to do it as one big long inequality, but you can feel free to rewrite it that way. Oh, that was supposed to be equal to there. Okay, here's what I'm going to do. I'm going to get x alone, right? First I need to subtract 9, but I'm going to need to subtract 9 on all three sides. Just like that. I think this is a pretty nifty way to do this. So negative 6 minus 9 is negative 15. Less than or equal to 3x less than 21 minus 9, I believe, is 12. Now the x is still not alone. I need to divide by 3. But when I do that, I have to do it on all three sides. So I end up with the inequality of negative 5 less than or equal to x, which is less than 4. Now for this one, this solution here means that my x value can be negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Can't be 4 though, because there's no equals there. Could be all those fractions and decimals in between there. So I'm going to show negative 5. I'm going to show positive 4. I know that at negative 5 I need a closed point. How do I know this? Because it says equals to. And on positive 4 I need an open point. And I want to shade everything between the two. Any number I pick in here will make this inequality true. Any number I pick less than negative 5 or greater than positive 4 or including positive 4 will make the inequality false. This is the solution set right here. All right, let's try one more problem. Very similar idea. I'm going to subtract 5, subtract 5, and subtract 5. Try to get my x alone. And when I do that, I'm going to get negative 10 is less than negative 2x, which is less than 0. And then I'm going to divide by negative 2 to get the x alone. And this will become 5. Whoop, 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 whoop. Because I divided by a negative, that inequality will flip. In the middle, I'll get an x. Whoop, 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 whoop. I divided by a negative, the inequality will flip. 0 divided by negative 2 is 0. So this one will look like this. I'll show 0 on the number line. I'll show 5 on the number line. In this case, both circles, both points will be open. And again, I need the numbers 5 is greater than, and those numbers must also be greater than 0. So I need all the numbers in between 0 and 5. Now that's not a coincidence. Last thing I'm going to mention before I let you go for the night is that when you have an OR, almost all the time ORs will graph like this, or they could be open points pointing away also. So these are ORs. Okay, that's what ORs look like. There's a couple freak exceptions, and I'll talk about those in class one day. If I have an and, my ands might look like this. Then again, they might, oh, hold on there. Sorry about that. They might look like this. Okay, now again, there is a freak exception, and I'll talk about those in class one day. All right, that's it for tonight's lesson. Mr. Lawrence signing off. Good night, everybody.